Bismillahirrahmanirrahim. Greetings. Let me introduce the highlights of the lecture verbally in advance before I put the material on the board and go over them pictorially as an illustration or demonstration. Now, creating mental images of a lecture material is a powerful strategy to deeper understanding the concept of the subject of the lecture and also retention. And for this reason, I usually in a live audience, I practice that one for the first few minutes of the lecture. So let's get started for today's lecture, shall we? Now, consider x comma y a point order per point in a Cartesian coordinate system that we are familiar with, we have been exposed to when we first were introduced to analytical geometry in junior high. Now, the x component, x is a letter. It can be any other letter you want. You can put L and for the y you can put maybe V. The x component, the first component of the order pair, indicates how far the point is located away from the origin horizontally. And the y component, the second component of the order pair, indicates how far the point is located away from the origin vertically. So by doing that, we get a precise address location of the point. You follow me so far? Now, if we swap the x and y of the order pair, then what happens? No, the location of the initial location of the point now is changed. The order pair is very important, this word, because if we drop the order from that, this will not happen. Now the new location is related to the initial location in a sense that how far the point was located away from the origin vertically now is how far the point is located from the origin horizontally. And same is true for the other one, for the x. Now, this motivates the idea that why don't we swap the entire x and y axis. The entire x and y axis we swap by rotating them 90-degree clockwise with respect to the center 0, 0. And so that the reason, excuse my voice, the reason this motivated the idea because the point that we selected was an arbitrary point. So that is the case for any other points. And because a relation or a function or a geometrical figure or any figure in the coordinate system consists of infinitely many points. And what we just mentioned about the single point holds for all other points. Now, just for the clarity, let's assume that our point x comma y is located in the first quadrant. All right. Now, when we swap x and y, both x and y will also be positive because x and y was positive. Now y and x will be positive. That's what we're expecting. Now, but when we rotate that on 90 degree clockwise with respect to the origin, now every point in the first quadrant now is landing in fourth quadrant. And in fourth quadrant, the horizontal component is positive, but the vertical component is negative. But that is not the case for all points, because when x and y are in first quadrant, when we swap, they both are positive. We swap again, they are positive. So then this gives the motive, the idea that we take and reflect the entire plane about the horizontal axis, then that point now will land on first quadrant. You follow me? Now, in that case, x and y has been swapped, and both are also positive because the initial point was x and y component of that was positive. Okay, then now I have the model for that I made, but if I demonstrate it like that, because I'm your mirror image in a sense, so the quadrant will not be consistent. So I put that one, I back myself and I put it on the board so that you are facing that. I'm not facing you, excuse me, but it's a normal in the same direction. You know what I'm talking about. So that, because again, I repeat myself, I'm lecturing, I'm a mirror image of you, in a sense. Okay, then let me zoom this one and go over them and illustrate all this what we said pictorially, demonstrate them. So let me go for this one first. Here, here is my point, all right? Now, when I rotate this one 90 degree clockwise, you see, look at that. The point falls in the fourth quadrant. But as I already mentioned, in fourth quadrant, the horizontal is positive, but the vertical is negative. But the point was both will be positive. So if I reflect that one about the horizontal axis, look at what happened. The point falls into the first quadrant. And that is the case for any other quadrant, in fact. But I'm just, for the sake of demonstration, I selected the first quadrant. You follow me? Okay. Now I have put this one also. Let's go over this one for extra explanation. Is that this is my point. And as a matter of fact, this is in a scale. All right? 1, 3, the point. The point is arbitrarily point x, y. Now, when I rotate that one 90 degrees, I have another one I will show you. Then the point falls into the fourth quadrant. You see that? And in order both to be positive, I reflect that one about the horizontal axis. Now the point is landing here. So fortunately this shows up the other side of the sheet is a thin sheet I selected. Now this is the initial point, and that is rotation and reflection, which lands here. So later we notice that there is a good relation between them, and that is their mirror image of each other that we are going to investigate for that. You follow me so far? Okay, now let me go to next one. Next one is the one that we mentioned in the previous lecture, Mr. Rogers make-believe. So we go to the flatland. And in flatland, we call this guy Mr. Gobbledygook, and he's laying down here. You see that? So that is a relation. because relation, as we mentioned in the first lecture, is any subset of the Cartesian coordinate system. R cross R, we call it relation. Now look what happens. I take, according to the strategy we developed, look what happens is I rotate this 190 degree with respect to the origin. All right. Now look what happened. The Mr. Gobbledygook is the same Mr. Gobbledygook. He has not changed. You see that? But he has fallen into the fourth quadrant by doing that. Now, if we reflect that one about the horizontal axis, look what happens. The Mr. Gobbledygook now lands to the first quadrant. It was originally there. So originally was here. Now the way that it was laying down is in there. But the Mr. Gobbledygook is the same one, because I have a point for that when we continue further. Now I have the picture of the Mr. Gobbledygook and its image, in a sense, together. So let me put that one up for you and make sure that it's zoomed good. Let me check the zooming part of it, if I may. That's good. Now, this was Mr. Gobbledygook in the initial position, and this is after rotation and reflection. This is where he falls. Now, these two are related to one another. We are going to see and investigate that one. Now, let's go to some mathematical function relation situation. Now, consider the set of all ordered pairs x and y such that y equal to x squared. We are very familiar with that. It's parabola. We have seen it so many times. And then I have put some points here, collect some points. And these two are same, because I just took a square root of both sides. And the table also shows they are same. So they will have same graph. All right. Now, let's see how the graph of that will look like, that we are familiar with. Are you comfortable with this? Now, the graph of that is a parabola. So what is parabola? We know that parabola is a function. And we know from junior high school that in order to find if a relation is a function or not in coordinate system, we use certain things that we call it vertical line test. And if vertical line pass, then we call it that graph, that figure is a graph of a function. Now here, this will pass the vertical line test, every point of that. But this function is a 2-to-1 function. What do I mean by 2-to-1? Means any 2 points that they are, they have the same absolute value with respect to the origin, they will have same image. That means, look at this one. When I give him 3 input, the function gives me 9 as an output. When I give -3 as an input, the function again gives me 9 as an output. So we call it 2-to-1 in a sense. But this does not violate the uniqueness part of the definition of function. Because when 3 is paired with 9, 3 is not paired with anything else. So the uniqueness has not been violated. Now, if we use the technique that we just, in a sense, discovered, which is, we call it rotation reflection, let's rotate this one with respect to the origin first 90 degree. all right? And then reflect it with respect to the vertical axis, and look what happens. The figure, as you notice, is no longer function in a sense. It's not a graph of a function. Let me see if the zooming is okay. Okay, now the vertical line test is failing. Is that right? So this rotation and reflection of the function that we had of parabola give us the, in a sense, the inverse of that, but the inverse of this is no longer function. The better way to say that, we can say, is a multi-valued function. And the first one was this one, as a matter of fact, we call it multi-valued function. But in order to make it a little bit simpler for the especially beginners, we just simply say it's not a function because vertical line test will fail. Now, then the question comes, if we restrict the domain of this parabola function to either positive or non-negative axis, let me do that. If we restrict the domain of this function, only the right half of the parabola, then this, we call it a one-to-one function. It's not 2-to-1 anymore, it's 1-to-1 function. And if this is the case, if we restrict that to this, then when we rotate and reflect, the image of that will also pass the vertical line test. That means the image of that will also be a function. So I have that one. Let me put this one up for you. Now, this is the set I mentioned, all right? So I mentioned the set of all xy such that y equal to x squared, which is our parabola, but I restricted the domain of that for all non-negative real numbers. So this is the set we are dealing with. And now, let's see when we restrict that, what happens. Now, I have restricted, all right, and this 3,9 point is not in a scale, as a point example. Now, we use the technique that we mentioned, the rotation reflection. We rotate that 190 degrees about the origin, and then we reflect it about the horizontal axis, and look what happens. Fortunately, this paper is thin, and it shows the other side of it, and look what happened is a beautiful, beautiful, beautiful function, and the vertical line pass, definitely. So that means what we can conclude is that the relation in the coordinate system must be what? Must be, we call it one-to-one relation, or one-to-one function. Another word is what? Is a one-to-one correspondence. The fancy word for that is should be injective, or in a sense bijective, we can also say. So the graph should be injective graph. The function should be injective in order, therefore its inverse, rotation reflection, can also be a function. Okay, now I have another demonstration which is in a scale, just for the sake of the extra word, is that this is in a scale. So this is the arbitrary point that we selected, which is 3, I made just 8, y, I selected 3,9 for better visually we can comprehend it better. Now, when I rotate this 190 degrees, clockwise, look what happens. The point I covered it, the point now will be 9 negative 3. Is that right? 9 comma negative 3. So 3 comma 9 becomes 9 comma negative 3. And when I reflect it 180 degree, look what happens. The point now is in the first quadrant, and the coordinate of that is 9 comma 3. Originally was 3 comma 9. Now after rotation reflection, it becomes 9 comma 3. You follow that? Okay, now there is a good observation for that. The observation is this, that if we connect the, let me see, this is the other side of it. Let me, let me put it this way. Now the point is that if we connect these 2 points, connect them, a line segment will be formed. The middle of this line segment will be the mirror of for these 2 points, which means there are 2 what? They are mirror image of each other. Let me zoom this one on and say a few words in verbally before I continue. You know what I just said? If we connect the 2 points, we get the line segment, and the midpoint of the line segment is going to play as a mirror, in a sense, of the 2 points, the mirror. So the 2 points will become mirror image of each other. But the good question to ask at this point is that this is the case for any 2 points, any 2 distinct points in the plane. If we connect them, the middle point of that will be mirror image of that. So what is so fast about this one you are mentioning? Now the difference is that these 2 points that we selected, they are related. They are related to one another in the sense that one of them is swap of the other one. So we are not talking any 2 points randomly in the plane. We are talking about 2 points that they are related to one another. And then in that case, yes, the midpoint of the 2 points will be mirrored in a sense that if we connect that midpoint, we can very easily find the coordinate of that midpoint. x1 plus x2 divided by 2, comma y1 plus y2 divided by 2, a basic algebra. And then if we connect that point to the center, 0, 0, and continue, a line will be formed, and that line is a 45-degree line with respect to x or y axis, either of them. And we call it y equal to x line. And that line ends up to be the mirror for any relation in Cartesian coordinate system, any whatsoever relation. Now let me go to that one that I have and show this one pictorially. Let me now zoom that one back, if I may. Now here, excuse me, let me go back to this. Now that Mr. Gobbledygook, Mr. Rogers might believe in flatland. Now look at this one. This line, 45-degree line, will be the mirror of these 2 pictures. As you can see, their feet is touching the mirror. Is a fascinating, is a mirror image of that 45 degree. You see that? All right. Now, let me do that with the graph that we had, with the parabola that we restricted the domain of that. So what we did, let me go to that one more time, and that is our right side of the parabola, right half of it. We rotated and reflected, and we got this one. Right? Now let's put this one together. The original and the reflection of that. The original half a parabola and the rotation and reflection part of it. All right. Now look what happens. This is our f of x equal to x squared parabola that we are familiar with. Is that right? Now we did make a 90-degree rotation about the origin clockwise, and then we reflected, and this figure came out of it. All right? And look what happens. These two figures are mirror image of each other with the line y equal to x. Isn't that fascinating? Look at that. So that is another way to test to see whether a function which must be one-to-one, if that is another way to find by taking this one to be mirror, and then with respect to that find each other points for that, and they graph with that. You can do that. And most of the textbooks, they do it this way, in fact. But rotation and reflection, there is more kind of mathematics involved in that. All right, now the last one that I would like to hang on the board is this one. And that is also very important. And it is when if a function is one-to-one, correspondence, let's say one-to-one and onto injective, then in this case f of x equal to x squared, and my inverse ends up to be f inverse is a square root of x. Now if we compose them together, and hopefully you are familiar with composition of function, if we compose function and its inverse, we always end up with the same input will be output, which will be identity, we call it. And also we have to test the second part also. If we compose the inverse of the function and the function, again, the input will be the same as output. And we can even use this one to be kind of, this property, we can use it as a kind of definition of a function and its inverse, and say that a function and its inverse, they are what? A function has an inverse. If we compose them together, the composition of them will be identity. So we can make even a kind of formal definition of that. Okay, then let me zoom this one back, say a few more words, and we close for today's lecture, if I may. Okay, one thing I always say to my students, and I encourage you to do the same, this concept is very important to demonstrate for your little sons and daughters, hopefully if you have your children, or your younger brothers and sisters. And this rotation, the reflection that I demonstrate that one, is just not for that, for any other thing, is even grade school, 3rd and 4th grade school student can fully comprehend it. And if you do that, you're really expanding their mind and making them their future easy for any mathematics or science related subject they will be taking. So you will be doing a great favor to them that unfortunately was not done to me. Okay, now the other thing we mentioned is that this is the advantage of what? Advantage of demonstration, in a sense, to fully comprehend it. The other one is that in almost every textbook I have seen, and also in YouTube tutorial, not 9 out of 10, but 10 out of 10, they just say for inverse of a function, they mention to change x to y and y to x, then solve it for y. It is correct, you get the right answer, but the mathematic part of it is missing. Is a step following, is a recipe following, that I call it cookbook style of following, that belongs to the kitchen in reality. So if you want to be a scientist, to have a good future for yourself in the field of science and mathematics, try to always demand justification and see where the motive of something was that unfortunately was not mentioned to you either in live class or in a textbook. So you have to dive yourself into that and try to find it for yourself. This is my advice to you, because myself I have suffered quite a lot in life because of this important concept that the system did not give to me, I was lacking. Okay, then I thank you for watching. I hope that my channel is productive to you. I'm not doing that for any kind of money from YouTube. I'm doing that for the service of the public. First, for my fellow American citizen, and second, for any other nation, any other nationality, any other part of the world that they may benefit from these lectures. Okay, then I always end up with an army salute and say thank you again for watching. Have a nice, prosperous, and happy day. So long.